blood transfusions are sometimes necessary because your cardiovascular system can only do so much to minimize the effects of blood loss that you can read here. But once you get to over 15% of your blood lost, things start to occur. Then it can get potentially fatal once we get to 30% blood loss. So death and shock may result from low blood volume. That volume must be replaced immediately. So the most important primary step is the volume of fluid. So saline could be injected, or multiple electrolyte solution like Ringer solution in emergency situations to replace that blood volume, because remember, you need adequate blood pressure and volume to get that blood pumped to all parts of the body. So replacement of volume restores circulation, which is step number one. But that's not going to replace oxygen carrying capabilities of your red blood cells. Red blood cells have hemoglobin, which carry oxygen to the tissues. So this saline or Ringer solution only accounts for the volume, which is extremely important, but is half the battle. So we're going to look at different types of transfusion. They last about a month. Shelf blood lasts about a month. Whole blood transfusion just means blood is taken from one person, that the whole content of that blood is injected into someone else, is only used when the blood loss is rapid and there's a lot of it. But when blood is donated, oftentimes it's separated into components. So someone can be infused just with packed red blood cells. Remember the blood in the centrifuge? We had 45% of it as erythrocytes, so those are packed red blood cells. And, well, there's the acronym right there. That's the plasma being removed, the white blood cells being removed. We're left with packed red blood cells, and that's what's preferred to restore the oxygen carrying capacity, because it's the red blood cells or erythrocytes that contain the hemoglobin for oxygen transport. There's something called autologous transfusions. Auto means self, so that's blood taken from a person and stored in the event perhaps the person is having surgery. So if they need blood, they can just use their own blood, which is obviously preferred in a situation like that. Human blood groups. So our red blood cells, if you can picture your red blood cells, have antigens on the surface. Those antigens, I'll draw a blood cell. So on the surface we have something called antigens, which are typically glycoproteins, thousands and thousands of them. I just drew two. They're referred to as agglutinogens. A glutinogen is an antigen on a red blood cell. Now, an antigen is something that's going to provoke an immune response if you don't have those antigens yourself. So if you put this blood cell in another person who doesn't have these antigens, well, that body is going to attack. That immune system will attack these cells to destroy it. That's why we have to blood type to make sure they're compatible. There's lots of naturally occurring red blood cell antigens. Here's some lesser known ones, but the most common ones that will produce severe reactions if it's transfused into someone who doesn't match is the ABO antigens and the RH blood groups. They cause the most vigorous, like it says, transfusion reactions, and they're the ones we're going to look at here. So looking at the ABO blood group first, someone with type A blood, I'll just draw that here, they have type A blood, they're going to have A antigens, a specific antigens that we call A, or agglutinogens. There's the word agglutinogens. Someone with type B blood, forgive my drawings here, is going to have a different looking antigen called the B antigen, or the B agglutinogen. If someone is AB, that's an AB, they have both A antigens and B antigens, or A and B agglutinogens. Now, if someone in the ABO system here, if someone has certain antigens, they have antibodies against the opposite antigen. Remember, an antibody is your immune system. These are chemicals that attack something that's foreign. So someone who has antigen or agglutinogen A will have antibodies for B. So if we try to put this cell in this person, the antibody will join on and attack that cell. Now, someone with type B blood will have type A antibodies. Agglutinins is another term for antibodies when we're talking about this AB system. So someone with type B blood, if we try to put this cell in that person, well, this antibody or agglutinin will join on and attack it and destroy the cell. So someone with type AB blood does not have either antibody, does not have either agglutinin, because if it did, it would attack itself. Therefore, it doesn't have any of those agglutinins. There's also type O, someone with type O. That means they don't have any antigens on the surface of their cell, no agglutinogens, the same thing as antigens, but they have both antibodies, right? And the antibodies will attack either an A, a B, or an AB from entering their system. So something to bear in mind here, antigens are on the surface of the cell, also called agglutinogens, just match the gen. And does it say antigen anywhere? I guess it doesn't. Antigen, agglutinogens, same thing. The antibodies in the blood are also called agglutinins. So these words can get mixed up. Remember, they're opposite. These are agglutinogens. This is an agglutinin. Antigen, antibody. So here's a good summary. Someone with blood group AB has both antigens or agglutinogens, A's and B, but they don't have antibodies or agglutinins. If they did, their body would attack their own blood, and that won't work out. Someone with B blood only has B antigens, but A antibodies, or agglutinins. Someone with A, of course, opposite of B. Someone with O means zero, no antigens. The surface of their cells have nothing on them as far as the ABO blood group goes. But they have both antibodies, both agglutinins, which will attack any of these antigens on any of these three other cells. So because of that, O is considered the universal donor because there's nothing on the surface of their cell to attack. There's no antigens. There's no agglutinogens. AB is the universal recipient because they don't have the antibodies to attack an ABO antigen. And then, of course, someone who has B can receive from B, but they can also receive from O, the universal donor. Same with A. They can receive from someone with the same blood type or the universal donor. O can only receive from themselves. So this is just a summary of what we went over. With the ABO system, type O, universal donor, no A or B antigens. AB is the universal recipient because no anti-A or anti-B antibodies. But it says, however, other agglutinogens that cause transfusion reactions must be considered. The plus or the minus. You might think, well, what if someone's A positive or A negative? What does that mean? And I think we'll get into that on the next video.